Now we are going to see how to add two matrices. Can we add two matrices? We already know what is the order of the matrix, how to equate two matrices. Now we are going to see when to add and how to add two matrices. Addition of two matrices is possible only when the matrices are of same order. If the matrices are going to be of same order, then we can add them. Okay. Then how to add? Then corresponding elements will be added. We know what do you mean by corresponding elements. We know when we equate two matrices, we used to equate the corresponding elements of the matrices. Okay. In the same process, when we are going to add two matrices, the two matrices must be of same order. In that case, we must add the corresponding elements. Is it clear? Now, if A is a matrix of order 3 by 2 and B is also a matrix of order 3 by 2, then A plus B is possible. We can add the matrix. How to add? In that case, we must add the corresponding elements. So, if it is A matrix is going to have 3 rows and 2 columns, A11, A12, A21, A22, A31, A32. This is your A matrix, and B matrix again 3 rows and 2 columns, B11, B12, B21, B22, B31, B32. In that case, we add the two matrices A11, A12, A21, A22, A31, A32 added with the second matrix B11, B12, B21, B22, B31, B32. So, in that case, how to add? The corresponding element must be added. First row, first column element should be added with first row, first column element of the second matrix. So, it will be A11 plus B11. Then, first row, second column element will be added with first row, second column element of the second matrix. So, A12 plus B12. So, first row elements are added. Now, we are going to add the second row elements. A21 will be added with B21. So, A21 plus B21. Then, second row, second column element, second row, second column element will be added. A22 plus B22. Similarly, third row element A31 added with B31. A32 added with B32. So, this is how we have to add the matrices. Is it possible to add 3 matrices? Yes, we can add 3 matrices. We can add any number of matrices using the same concept. Is it clear? So, the basic condition to add 2 matrices is they must be of same order. They must have same number of rows and same number of columns. Then only we can add 2 matrices. Okay. Now, let us discuss some of the properties of addition of matrices. Few properties. What are the properties? Matrix addition is commutative. What do you mean by commutative? We can say in the order of addition. A plus B will be equal to B plus A. Both will give you the same answer. A plus B will be equal to B plus A. This is called commutative property. Commutative property, first property. The second one is associative property. A plus of B plus C will be equal to A plus B plus C. This is called associative property. We can add B plus C, then the answer can be added with A, will be same as A and B added first, then C is added to the answer. Both will have the same value. A plus of B plus C is equal to A plus B plus C. We can say in the brackets. Okay, that is the meaning. Next, existence of identity. That is, any matrix can be added to the null matrix of the same order. Then we get the same matrix. 0 plus A or A plus 0 will be equal to A. Existence of identity. Is it clear? Then inverse. For every matrix A, we know that negative matrix of A, it is nothing but minus A. So, A plus of minus A will be equal to minus A plus A. The answer will be equal to null matrix. So, the previous one is called existence of identity. With respect to addition, the next one is existence of inverse. Existence of inverse. Okay. So, when we can add two matrices can be added only when they are having same order. Then how to add? The corresponding elements will be added, and these are the few properties. Now, can we subtract two matrices? Is it possible to subtract two matrices? A minus B, is it possible or not? Can we subtract the matrix B from A? Yes, we can. For that, we must understand the concept. A is added with negative matrix of B. So, this is the meaning. So, whenever we try to subtract, we change that subtraction to addition with negative matrix. Is it clear? Suppose if I am having A minus C, then this will be rewritten as A added with negative matrix of C. So, and we know when we can add two matrices, again the matrices should be of same order, then only we can perform the subtraction also. Is it clear? So, if A is a matrix of order m by n and B is also a matrix of order m by n, then we can subtract. A minus B is possible. And how to calculate this A minus B? A minus B is calculated by A plus of minus B. Is it clear? And we know that subtraction is not commutative actually. That is, A in matrix subtraction, A minus B cannot be equal to B minus A. Is it clear? That means commutative property is not valid. Commutative property not valid in matrix subtraction. What about associative? Associative property also not valid, because A minus of B minus C is not equal to A minus B minus C. They are different. We cannot equate A minus of B minus C with A minus B minus C by changing the brackets. So, associative property also not valid in matrix subtraction. Okay. But we can find A minus 0 is equal to 0 minus A, we can perform. Okay. So, this is with respect to subtraction of two matrices. Okay. So, if A is a matrix of order 2 by 2, for example, A is a matrix of order 2 by 2, namely A11, A12, B1, A21, A22, and B is also a 2 by 2 matrix of same order, B11, B12, B21, B22. Then can I subtract A minus B? A minus B will be equal to A matrix is A11, A12, A21, A22. Now we are having this minus, okay, minus of B11, B12, B21, B22. We have one more step, converting that to minus to plus. So we write A11, A12, A21, A22 plus of, converting this B matrix to negative matrix of B, that is minus B11, minus B12, minus B21, minus B22. So now that subtraction is converted to addition. Now to add these two matrix, you have to add the corresponding elements, that is A11 minus B11, so A12 minus B12, so A21 minus B21 and A22 minus B22. Okay. From here we can easily see, when you want to subtract two matrices, the same process, the corresponding elements will be subtracted. But mathematically we cannot subtract two matrices directly, we have to convert that subtraction to adding with additive inverse of. Now we are going to see scalar multiplication of a matrix. Scalar multiplication of a matrix. A is a matrix of any order and K is a non-zero value. Then K into A is called scalar multiplication of matrix A with a non-zero scalar K. Is it clear? Suppose if I have a matrix with the order 2 by 2, 5 minus 4, 3, 2. I want to find 3 times A, 3A. Is it clear? So I want to multiply matrix A with a non-zero number 3. So it is 3 into 5 minus 4, 3, 2. How to perform this matrix multiplication, scalar multiplication of matrix? Multiply the scalar to all the elements of the matrix. We have to multiply the non-zero number with all the elements of the matrix. So we multiply 3 inside. So it is 15 minus 12, 9, 6. So this is the answer. Can I multiply with a negative number? Yes, of course we can multiply. Minus 5A will be equal to minus 5 into 5 minus 4, 3, 2. How to multiply? Multiply that non-zero number with all the elements of the matrix. So minus 5 into 5, minus 25, minus 5 into minus 4, plus 20, minus 5 into 3, minus 15, minus 5 into 2, minus 10. So, for scalar multiplication, we must multiply the scalar to all the elements. We must multiply to all the elements of the matrix. So, this is how the scalar multiplication is performed. So, here we are going to see problem based on addition, subtraction and scalar multiplication of the matrix. Now, consider this problem. A is equal to, what is the order of this matrix? 2, 4, 3, 2. It is 2 by 2, 2 rows and 2 columns. B, again first row, second row, this is first column, second column. So, how many rows this is going to have? 2 rows, and how many columns it is going to have? 2 columns. So, it is of order 2 by 2 again. What about the matrix C? It is going to have first row, second row. So, it is going to have 2 rows, and how many columns? The vertical arrangements are going to be columns. So, this is the first column, this is second column. So, this is also of order 2 by 2. So, the matrices A, B, C are going to have same order. So, we can add, subtract. Okay. So, what is the question asked? Find A plus B. Find A plus B. So, how to find A plus B? A plus B. I write A, matrix A. 2, 4, 3, 2 plus 1, 3 minus 2, 5. Because the matrices are of same order, I can add. How to add? The corresponding elements will be added. What do you mean by corresponding element? First row, first column element of matrix A should be added with first row, first column element of matrix B. So, what is the first row, first column element? 2. 2 added with first row, first column element 1. So, first row, first column element, first row, first column element added 2 plus 1. Next, first row, second column element 4 added with first row, first column element of the second matrix 3. So, we added the elements of the first row first. Then we move on to second row. Second row, first column element is 3. Second row, first column element of the second matrix is minus 2. So, this is 3 minus 2. Okay. This is written with minus because this element is going to have minus symbol. Next, second row, second column element of first matrix added with second row, second column element of matrix 2. So, it is 2 plus 5. So, what is the answer now? These two elements are going to have same sign. So, we add 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. So, this is the value of A plus B matrix. So, we found out what is the value for A plus B. Next, we try to find out what is 3A minus C. 3A minus C. Okay. So, let me calculate what is 3A minus C. 3A minus C. A matrix alone given to us. Okay. 3A we are supposed to find. What is 3A? Multiplying matrix A by this non-zero scalar 3. So, this is 3 into A. A matrix is 2, 4, 3, 2 minus of C matrix. C matrix is going to be minus 2, 5, 3, 4. So, I told you for subtraction we must convert this minus to plus by changing the second matrix to negative matrix of it. Okay, that is A minus B will be equal to A added with negative matrix of B, that is minus B. That is A minus B will be rewritten as A plus of minus B. So, same way here we are changing this. I multiply this scalar 3 inside. How to multiply scalar? We have to multiply the scalar to all the elements. So, this is 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 2s are 6. I multiplied and I change this minus to plus, by which the second matrix is converted to negative matrix of itself. So, minus of minus 2 is plus 2, this is minus 5, this is minus 3, this is minus 4. Now, the subtraction is converted to addition. So, I perform the addition now. How to add? Because these two matrices are of same order, corresponding elements will be added. I add. So, 6 plus 2, 12 minus 5, 9 plus of minus 3, which is nothing but 9 minus 3, last one 6 minus 4. So, we simplify this expression. 6 plus 2 is 8, 12 minus 5, different symbol. So, subtract, 12 minus 5 is 7, 9 minus 3 is 6, 6 minus 4 is 2. So, this is the answer. So, this is how we have to add and subtract two matrices. Here in this problem we learn how to add two matrices, and the same problem we do scalar multiplication with a matrix and then we subtract two matrices. We move on to next problem. Now, read the question. If A is a matrix with entries 1, 2, 3, 2, 3, 1 and B is a matrix 3, minus 1, 3, minus 1, 0, 2, then find 2A minus B. So, what is 2A minus B actually? 2A minus B is nothing but scalar multiplication of 2 with the matrix A plus of minus B. Is it clear? So, we start solving the problem. So, first we understand what is the question is, then we start. So, A matrix is 1, 2, 3, 2, 3, 1 and B matrix is 3, minus 1, 3, minus 1, 0, 2. Okay. Now, we are going to calculate 2A minus B. We are going to calculate 2A minus B. So, 2 times your A matrix, that is 1, 2, 3, 2, 3, 1. This is your A matrix minus of B matrix 3, minus 1, 3, minus 1, 0, 2. So, we multiply that scalar inside, because scalar multiplication of matrix we have to multiply the scalar to all the elements of the matrix. So, this is 2 ones are 2, 2 is multiplied with the 2, 4, 2 is multiplied with the third element 6, 2 is multiplied with the 2, it is 4, 2 3s are 6, 2 ones are 2. And here minus, this minus is converted to plus. When you convert this one to plus, this minus is multiplied inside again for all the elements. So, converting the matrix to its negative matrix, because it is subtraction. So, minus 3 plus 1, minus 3 plus 1, 0, minus 2. And this is of matrix of order 2 by 3 and this also of order 2 by 3. We can add now. So, when we are going to add, the corresponding element should be added. So, here the first row first column element is 2, here first row first column element is minus 3. So, we simplify 2 minus 3. Next one, first row second column element will be added with first row second column element of the second matrix. So, it is 4 plus 1. Same way, first row third column element added with the first row third column element, it is 6 minus 3. Next, so first row element we added, we move on to the second row, that is second row first column element is 4, this is added with second row first column element plus 1. So, it is 4 plus 1. Next one, 6 plus 0. The next one, 2 added with minus 2. So, 2 minus 3 is minus 1, 4 plus 1 is 5, 6 minus 3 is 3, 4 plus 1 is 5, 6 plus 0 is 6, this is 0. So, the order of the matrix is again 2 by 3. You can see from the previous problem and this problem, the order of the resultant matrix is also same as the order of the matrix what we add or subtract. Okay. So, in the question it is given 2 by 3 matrix, here also 2 by 3 matrix, we add, the resultant matrix is also of the same order 2 by 3, the order of the matrix is not going to change. Okay. Let us move on to next question. Now, see this question, if the matrix 9 minus 1 4 minus 2 1 3 equal to A plus of 1 2 minus 1 0 4 9, then find the matrix A. We are supposed to find the matrix A with this condition. So, what is the question now? A plus of 1 2 minus 1 0 4 9 is equal to 9 minus 1 4 minus 2 1 3. We are supposed to find the value for this matrix A. We can very well see this matrix is of order 2 by 3 and the answer is also of order 2 by 3. Naturally, matrix A is also of order 2 by 3. Okay. Now, how to find the value for A? Now, this matrix 1 2 minus 1 0 4 9 is in addition with A. So, I want to eliminate that as usual by additive property. Suppose if I am having A plus C is equal to B, if I want to remove this C, what I should do? Add with additive inverse, minus C equal to B minus C. So, C will get cancelled. So, A will be equal to B minus C. Same concept we are going to use. So, left hand side it is A plus of 1 2 minus 1 0 4 9. I am going to add with additive inverse of this matrix. What is the additive inverse of this matrix? 1 2 minus 1 0 4 9, negative matrix minus A. What is that? Minus 1 minus 2 plus 1 0 minus 4 minus 9. And the right answer also we have to perform the same thing. What is that? 9 minus 1 4 minus 2 1 3. I am going to add with additive inverse of matrix 1 2 minus 1 0 4 9. What we added on the left hand side, same thing we are going to add on the right hand side. What is that? Minus 1 minus 2 1 0 minus 4 minus 9. Left hand side, these two matrices are additive inverses of each other. It is going to be the additive inverse. So, if you add these two matrices, it is going to be null matrix. So, A added with null matrix. Right side, these two matrices are going to be of same order. So, we can add them. How to add? As usual, same procedure. How to add? Yes, exactly. Corresponding elements will be added. So, 9 minus 1 minus 1 minus 2, 4 minus 1, sorry, 4 plus 1, minus 2 plus 0, 1 minus 4, 3 minus 9. So, A is equal to 9 minus 1 is 8, minus 1 minus 2 is minus 3, 4 plus 1 is 5, minus 2 plus 0 is minus 2, 1 minus 4 is minus 3, 3 minus 9 is minus 6, 3 minus 9, both are going to have different symbol. So, subtract the smaller one from the bigger one and put the bigger number symbol, that is it, very simple calculation. So, this is the matrix A. So, matrix A is 8 minus 3, 5 minus 2 minus 3 minus 6. So, this is the answer for your A matrix, and if you substitute in this expression, you will get the required answer. Is it clear? Just we check it. Okay. 8 minus 3, 5 minus 2 minus 3 minus 6. I am going to add with 1, 2 minus 1, 0, 4, 9. When you add 8 plus 1 is 9, minus 3 plus 2, minus 1, 5 plus minus 1, 4, minus 2 plus 0, minus 2, minus 3 plus 4, plus 1, minus 6 plus 9, 3. Are you getting your left hand side or not here? 9 minus 1, 4, minus 2, 1, 3. We got it. So, this is the solution for A. 8 minus 3, 5, minus 2, minus 3, minus 6. So, we can solve the equations involving matrices also by addition and subtraction. Now, A is equal to diagonal 1 minus 2 5, B is also diagonal 3 0 minus 4, and C is also a diagonal minus 2 7 0. What do you mean by diagonal now? This is a new term what we are going to see. Diagonal. Okay. A is equal to, they are given like this. What is that? Diagonal 1 minus 2 5. That is, A is a diagonal matrix having diagonal elements 1 minus 2 5. So, how many elements we have in the diagonal? 3 elements. So, it is a diagonal matrix of order 3 by 3. So, what will be the entries now? A will be equal to 1 0 0 0 minus 2 0 0 0 5. This is the meaning of A is equal to diagonal 1 minus 2 5. The diagonal elements are going to be 1 minus 2 and 5. The remaining elements are 0. So, the short form of writing your diagonal matrix, A is equal to. Same way, we are going to see what is B matrix. B matrix is given by, again diagonal, and diagonal is going to have 3 elements 3 0 minus 4. So, how to write your B matrix? Tell me now. How to write the diagonal matrix B? It is given by diagonal 3 0 minus 4. So, the first row first element is 3, remaining element will be 0. Next one, the second diagonal element is going to be 0. So, this entire row is going to be 0 now. and the third element in the main diagonal element is minus 4. So, we have to write 0, 0, minus 4. In diagonal, we are going to have 3, second row, second column is 0, third row, third column is minus 4. What about C matrix? C is equal to diagonal minus 2, 7, 0. So, how to write your C matrix now? C matrix is minus 2, 0, 0, 0, 7, 0. The last row fully going to be 0. In diagonal matrix, we can have diagonal elements 0, but at least we must have one non-zero diagonal element, then only it is called as diagonal matrix. If all the diagonal elements are going to be 0, okay, then it becomes a null matrix. So, we must make sure in diagonal matrix at least one element in the diagonal is non-zero element. Okay. Now, we are supposed to find A plus 2b minus 3c. Okay, A plus 2b minus 3c. A plus 2b minus 3c. So, A matrix is 1, 0, 0, 0, minus 2, 0, 0, 0, 5 plus 2 into B matrix 3, 0, 0, 0, 0, 0, 0, 0, minus 4, and the last one is minus 3c. C matrix is minus 2, 0, 0, 0, 7, 0, 0, 0, 0. So, this is equal to, we simplify 1, 0, 0, 0, minus 2, 0, 0, 0, 5. Because we are having a scalar here 2, we must multiply that scalar inside to all the elements of the matrix. So, what you will get in that case? 2 3s are 6. The remaining element again going to be 0, because any number multiplied with a 0 will give you the answer 0. So, next 0, 0, 0. Next 0, 0, minus 8. Now, I will change this minus 3 to plus. Okay, I multiply minus 3 inside. Is it clear? Minus 3b or 3c, we can write plus of minus 3b. So, I take minus 3 inside. So, in that case, what you will get? Minus 3 into minus 2 is 6. Multiplying by any scalar with a 0 give you the answer 0. Next, minus 3 into 0, 0. Minus 3 into 7 is minus 21. Minus 3 into 0, 0. Again, this is 0, 0, 0. Okay. And you can very well see all the matrices are of same order. We can add the elements, corresponding elements, we can add it. So, we add corresponding elements. Here, first row, first column element. In the second matrix, first row, first column element. In the third matrix, first row, first column element. What is the answer we will get in that case? 1 plus 6 plus 6. Next one, we add the first row, second column element. So, it is going to be these 3 elements. Naturally, they are going to be equal to 0. 0 plus 0 plus 0. Same way, first row, third column element and all the matrices will be added. That is called as corresponding elements. Is it clear? So, this is the first row, third column element, and they are also going to be equal to 0, 0, 0. Now we are going to add the second row elements, corresponding elements we are going to add. So it is going to be 0 plus 0 plus 0. And second row, second element is going to be minus 2, 0, minus 21. It is minus 2 plus 0 minus 21. And second row, third element, all the matrices are going to be 0 again. So it is 0 plus 0 plus 0. Same way in the third row, 0 plus 0 plus 0, then 0 plus 0 plus 0, and then 5 minus 8 plus 0. We try to simplify each element of the matrix. This is 1 plus 6 plus 6. All the elements are going to have same sign. So we add 6 plus 6 plus 1. The answer is going to be 13. Again, next one, it is going to be 0. Then 0. Second row, first column element, 0. Here, minus 2 plus 0 minus 21. Okay. So minus 2 and minus 21. Same sign, negative. So we add and put the negative symbol. So it is minus 23. Next one, 0. Then 0, 0, 5 minus 8. Different symbol. So what we are supposed to do? We have to subtract the smaller one from the bigger one. So 5 is subtracted from 8. Answer is 3. And bigger number symbol is minus. So it is minus 3. So this is the answer. Now see this question. A is equal to 2 minus 3, 5, 0, and Ka will be equal to 8, 3a minus 2b and c. We are supposed to find the value for k, small a, small b, small c. Okay. How to start the problem? A matrix is given to us. Okay. A matrix is given to us. 2 minus 3, 5, 0. And Ka also given to us. K into A will be equal to 8, 3a minus 2b and c. Okay. Now we try to simplify this expression. K is written as such. A matrix is going to be 2 minus 3, 5, 0 is equal to 8, 3a minus 2b and c. So scalar multiplication of a matrix. K is going to be multiplied with this 2 by 2 matrix. Multiply, it will be 2k minus 3k, 5k, and this is going to be 0. K multiplied with 0 is 0, and it is equal to 8, 3a minus 2b and c. Now this is a matrix of order 2 by 2, and here also we are having matrix of order 2 by 2. So we can equate. We can equate the matrices. Now how to simplify this expression? Because these two matrices are equal, the corresponding elements will be equated. So we get 2k is equal to 8. I want to get the value for k, but 2 is appearing with k. So we try to remove that 2 which is in multiplication with k. So how to remove it? We know already, correct? We have to multiply by the multiplicative inverse of 2. So 1 by 2 into 2k will be equal to 1 by 2 into 8, by which 2 on the left hand side cancelled. So right answer we cancel this 2 with 8, 4. So we get k value is equal to 4. So, we got the value for K. Next one, we have to get the value for A, B and C. So, again we compare the corresponding elements. 3A is equated to minus 3K. Is it clear? So, 3A is going to be equal to minus 3K. So, 3A will be equal to minus 3 into K value is 4, we found out, minus 12. To find the value for A, I want to eliminate 3 on the left hand side. So, same process, 1 by 3. Why we have to multiply by 1 by 3? Because we are having 3 here, I want to remove 3. So, I multiply by multiplicative inverse of 3, 1 by 3. So, on the right hand side it is 1 by 3 into minus 12. So, 3 cancel. So, A will be equal to, when you cancel on the right hand side, it is going to be 4 3s are 12. So, A value is minus 4. Next one, we have to get the value for B now. So, we again compare the corresponding element. Okay, corresponding element in the second row, first column element will be minus 2B. Minus 2B is equal to 5K. So, minus 2B is equal to 5 into K value is going to be 4. What is 5 4s are? 5 4s are 20. Now, I want to eliminate minus 2. So, I multiply by multiplicative inverse of minus 2. So, 1 by minus 2 into minus 2B is equal to 1 by minus 2 into 20. So, minus 2 cancel on the left hand side. So, B is equal to, if you cancel 2 here, 10. So, the answer is minus 10. And finally, we have to get the value for C. Very simple. Here second row second column element, this also second row second column element. So, C value is directly equated to 0. So, what are the values we got? We got the value for K as 4, K is equal to 4, A is equal to minus 4, B is equal to minus 10 and C is equal to 0. So, this is the value for K, A, B and C. Okay. So, in this session, in this part, we found we are able to add, subtract and we can find the scalar multiplication of two matrices. Thank you, students.